All right, welcome to 7.5. In the investigation, we already learned about the law, angle of incidence, angle of reflection, and angle of refraction. And we're going to be able to use these and a few other methods to find out how to solve things, distances, through indirect measurement. So let's look at what indirect measurement is. So at times, measuring something directly is impossible or physically undesirable. When these situations arise, you can use indirect measurement, which uses proportions to calculate measurements. So there are four basic types of problems for setup where you'll be using similar triangles. And I'm just going to go over all four of these, and it's the same math that you would have got, like similar triangles that you've been solving for the last four sections. So this is the one we did in class, where the person's height relates to height of the tree, and then length, or the ground, relates to the height of the ground. I could also do 5.5 over 4 equals an unknown number over 16. Either way, if I do height over height, I have x over 5.5 equals ground, 16 over 4. Either way, when I cross multiply, I'm multiplying 16 and 5.5. So I would do this, I would do 16 times 5.5, or I guess in this case, I will just multiply each side by 16, get them to cancel. So the 16 times 5.5 divided by 4, so in this case, x is 22. So to set up a similar proportion, either way you want, and solve for the height of the tree. Another way is if the sun is up here, and it's shining down magical rays of sunshine, and this is the shadow. So this angle would be the same, whether I have my shadow at the exact same spot ending as the tree shadow. So this angle is the same. That means this angle, the right angle, is the same. So the triangles are similar. So very similar to the last one, I do 5.5 over 6. So it's my height over this width. And then that would equal the height of the tree over, in this case, I think 15 is from the person here. So I got to add the whole thing and get 21. So I'm going to multiply each side by 21 to get it to cancel. So 21 times 5.5 divided by 6. So this tree is 19.25. So next one, if there's a river, so these last two are for vertical heights. The next two are for horizontal heights. So if there's a river, I can start directly across and walk a known distance away, and my friend can start directly across and walk a known distance away. And our triangles will then be similar. So the 50 is my long triangle, and this length is my unknown side. And we'll get to this 5 in a minute. And then 50 relates to 12, and then this short leg is 5. And that would relate to this purple one. So in this case, since x is on the denominator, I will cross multiply, get 250 equals 12x. Divide 250 by 12, and I get 20.8 equals x. Now, because I couldn't be right on the shore, or Caleb couldn't, he had to go 5 feet across. So, and this, if we're trying to solve the width of the river, it would be 20.8 minus 5 would be the width of the river. So if we're asked to find the width of directly across the creek, it's going to be 15.8. So to do this one, you would have whatever distance you want to stand between. You'd each walk a known distance, and this person that's would have a distance this way as well as this way. This triangle is similar to this triangle because we have vertical angles here and a right angle. So by angle similarity. And the last way is more of a one-person way. If a person stands here and I want to find the distance between D and E, I will then set up two triangles. I could know this distance, or I would probably say I'm just going to put a meter stick right here. If this is 1 meter, I'm not even going in the water, but this is a story problem. Set up how it is. So 16 relates to the whole length. Notice if we just knew what this was, I'd have to add it, but we're given 35 equals 20, because this is the length across, and this is the length aside, 20 over x. So I'll cross multiply this, get 20 times 35, 700 equals, and then 16 times x, 16x, divide by 16, 700 divided by 16 gives me x equals 43.75 feet. So it's length, and I didn't have to get wet. So it's the length where I didn't get wet this way, and then the length across stacked up. So this relates to your project that you'll hopefully have time to do. The first one is if I'm in the commons, I want to find the length between the two pillars. So this way, not this way, because I'm standing right next to one. Do the width between the two inside edges. Now, if I'm set up where I'm standing right here, and we will say this is my focal point right here, I would draw lines to them, and then I would say, okay, well, I can't measure between them. That's not allowed in indirect measurement, but I do see that I could measure this length right here, from here on the table to here, and then I would measure this length, and then this length, and then I'd have the exact same picture like this. For this way, if you wanted to try this as well, you could, but I think this way would be easier. And then the second one you'll be doing is finding the height up and down. So I pick this spot. I'm going to pretend that right here is shining up to the top. You'll put the mirror somewhere. You'll measure the height from your eyes to the ground. Then you'll measure the width, the length from the mirror to you, and then the length from the mirror to the base. So this wouldn't be that great because I have to go over these tables, but you guys can find a spot wherever you want. So that's going to be your project, but before you can do the project, you got to do the homework and the Mathia. The You Do It is going to be on page 516, Talk the Talk number 1, where you're trying to estimate the height of the Washington Memorial. There's a reflecting pool, and it gives you the measurements, and you can see here that this up to here, I'm looking, so I'd have my length of water, and then my height, and I can measure the length. I know how long the pool is, I know how high I am. So that is this section.